Okay, so this is part 2 of solving rational equations. So I wanted to break this up again because I think it's a lot of information and it's good to kind of sit on it for a couple days and then come back to it. So let's see how much you remember from last time. So we're doing the same thing. The first step is to find the LCD. The LCD, you always look at the denominators here, and you're going to find the least common denominator. So when we see something like this, we always need to start with the x, just to factor it, right? So what adds to -7 and multiplies to 12, -3 and -4. So we can just go straight into x minus 3 and x minus 4, again, because the a is a 1. If this was any other number in front of this x squared besides just a 1, then we'd have to do the box, but not the case. So we're going to replace this with x minus 3 and x minus 4. And it matches both of these, which is a good thing. That means we only need 2 pieces for the LCD, which is x minus 3 and x minus 4, because every single piece of these denominators have either an x minus 3 and x minus 4 or both. So that's what our LCD is. Now we're going to multiply the whole thing by our LCD, which is x minus 3 times x minus 4. And we're going to see what the very first rational expression here is. See how it says 5 over x minus 3 and x minus 4? Both of these cancel out with both of these, so all we're left with in the first term is just a 5. Now here, the x minus 3 cancels out with this x minus 3, and I'm going to bring that 2 down, and I'm going to multiply it by what's left, which is x minus 4, because the x minus 3 is canceled out. Equals, and we bring the 5 down. The x minus 4 cancels out here, so we have 5 times x minus 3. And then we're just going to solve for x. Whenever, the reason we know to solve for x is because there's an equal sign. So it's an equation. Whenever there's an equal sign, we know we're actually solving for something. So here we just did 2x minus 8 equals 5x, 5 times x, minus 15. Combine like terms on the left-hand side, so 5 minus 8 is -3. I brought the 2x down, 5x down, and -15. And now we're going to move things around. So I'm going to add 3 to both sides. And we have 2x equals 5x minus 12, and then we're going to subtract 5x. So 2 minus 5x is -3x equals -12, divided by -3, x equals 4. Okay, so you see how this x equals 4? That's our answer for this whole thing, right? But we have restrictions we need to look at. So what are our restrictions? Remember, we set each of these equal to 0 to find the restrictions. If we can easily see what makes this 0, we don't have to set it equal to 0. Like if I plug in a 4, 4 minus 4 is 0, right? So one of our restrictions is x cannot be 4, because if I plug in a 4 here, it makes this fraction 0, and we can't have a 0 on the denominator. It doesn't make the fraction 0, I'm sorry. It makes the denominator 0, and we cannot have a denominator be 0. Here, what number would we plug in for x to make this equal 0? If we made x 3, 3 minus 3 equals 0, we can't have 0 on the denominator, so the restriction is also x cannot be 3. So those are our 2 restrictions. Okay, so now look right here what our answer was. Our answer was x equals 4, but look at our restrictions. So x is 4 here, but a restriction is it can't be 4, right? And let me do this. Restrictions really are x cannot be 3 or 4. So if x equals 4, but here x cannot be 4 because 4 makes the denominator 0, our answer here is no solution, since 4 is a restriction. Okay? So if you get an answer that is also a restriction, there's no solution, because you can't have something equal 4 but then say up here, oh, but it can't equal 4, right? That like contradicts itself. So there's no solution. Okay, number 5. So here, I saved an easier one for last, because look at the denominators here. First, I'm going to put that -x over 1, because I need a denominator. I want to look at all of my denominators, right? And I'm just going to put that over 1. So I have a 4, a 1, and an 8 for my denominators. So my LCD is going to be 8, because 8 times 1 is 8, and 4 times 2 is 8, and 1 times 8 is 8. All of these numbers go into 8, so that's my least common denominator. So remember, when I find my least common denominator, I multiply every piece by that LCD. And I'm going to look here, 8 times 1/4. Well, you see how there's a 4 here on the denominator? What's 8 divided by 4? Remember, we're always dividing this and this, so that's why we can just cancel. So 8 divided by 4 is 2. So 2 minus, okay, and then I have an 8 here, and I'm multiplying it here. Well, I can't cross anything out. 8 divided by 1 is just 8. So I'm going to multiply 8 times x, so minus 8x. Okay, and here the 8's cancel, so I have equals x on the right-hand side. So we're just multiplying 8 to every piece, right? Which all that means is we're dividing the denominator with this 8. So 8 divided by 4 is 2, 8 divided by 1 is 8, 8 divided by 8 is 1, and then we're just carrying everything else down here that we had in the original problem. Okay, combine like terms, so add 8x to both sides. So 2 equals, well, x plus 8x is 9x, and then to get x by itself, I divide by 9. We don't have any restrictions here since there are no variables in the denominator. So notice none of these denominators here, 4, 1, and 8, they don't have any variables. So we don't have to worry about restrictions. There's nothing that x cannot be, right? Because we're not going to plug anything into the denominator. There's no variables down there. Okay, almost finished. So some rational equations are called proportions. So a proportion is an equation where two rationals are set directly equal to each other. So if we go back, let me go back right here. Do you see how here we have a fraction, right? Minus another fraction, or just that x, right? Equals, and then another fraction over here. So do you see how we have like a plus or a minus right in between? It's 1/4 minus x over 1 equals x over 8. With a proportion, there's no plus or minus in between. It looks like this. Do you see how it's a fraction equals, and we can make that 9 a fraction by putting it over 1? When we don't have something adding or subtracting to either side, and we just have one fraction, an equal sign in between, and another fraction or whole number over here, we can solve using, this is called a proportion, and we can solve by multiplying across. So we can multiply the denominator to the numerator, and the denominator on this side to the numerator on this side. So we have 1 times 7, and I'm going to put it right here. 1 times 7 is 7. So 1 times 7 here. 2x times 9 is going to go on this side and keep the equal sign in between. So 7 times 1 is 7. 2x times 9 is 18x. And then we solve for x like normal. We divide each side by 18, and x equals 7 over 18. Okay, so we have restrictions on this one because there's a variable in the denominator. The restriction, and if you're not sure, remember, you can solve it like this. 2x equals 0. You always, if you're not sure what the restriction is, set the denominator equal to 0. Divide by 2, divide by 2. We're solving for x just to see what x cannot equal. So the restriction here, x cannot equal 0, because if we plugged in a 0 here, 2 times 0 is 0. And we can't have a 0 on the denominator. So if you're not sure, you can plug in it, or you can set it equal to 0 and solve. Okay, you can set the denominator equal to 0 and solve. So the restriction, x cannot equal 0. Okay, do you see here how this is different from the previous examples as well? Because we have a fraction over here equals another fraction over here. So we have two rational expressions that equal each other. Okay? And there's no plus or minus in between. What I mean by that is there's no like plus 3 over x. I don't know. If this was the case, we could not, so it's not a proportion because of this plus 3 over x over here. But if you have a rational expression, another rational expression, and just an equal sign in between, we can solve by using proportions. So we have 2 times 2 on this side, which is 4. And we have x times 3, x minus 3 times x plus 3 on the right side. Put an equal sign in the middle, and now we're going to distribute here. So we have 4. I'm going to bring that 4 down. X times x is x squared. X times 3 is 3x. Negative 3 times x is negative 3x. And negative 3 times 3 is negative 9. Now we're going to combine like terms. So we're going to bring that 4 down, and then you see the 3x minus 3x, that's 0. So we have x squared minus 9 because those cancel out. Okay, remember when we have an x squared, we don't have any other x terms. It's just an x squared, and then we have just numbers. We want to get that x squared by itself on one side, so I'm going to add 9 to both sides. And now I have 13 equals x squared. The reason for that is because to get rid of that squared term, to get rid of the x squared, we have to take the square root of both sides. And remember, when we take the square root, it's plus or minus. So x equals plus or minus square root of 13. Okay. Do we have restrictions? Yes. If we set the denominator here equal to 0, x cannot be 3. Last example. So again, we can put that 7 over 1 to make it a fraction. We have a rational expression that equals 7 over 1 over here, so we can, this is called a proportion, and we can multiply across. So 1 times 3x minus 1, and then 7 times x plus 2. Okay, now let's distribute that 7. So we have 3x minus 1 equals 7x plus 14. We're going to combine like terms, so subtract 7x. Okay, so 3 minus 7x is negative 4x. Bring that minus 1 down, equals 14, and then I'm going to add 1 to both sides. So negative 4x equals 15. To get the x alone, divide by negative 4, and we have x equals negative 15 over 4. Okay, the restriction here, if we set this equal to 0, the bottom, the denominator, x cannot equal negative 2. Okay, and that's it.